John. I work for Holland Pump. Today I'm going to be going over some facts and some benefits of using the Holland Rotary pump. So to start with, some of the features we put on our pumps are we have a couple different shutdowns, the dual tanks. We have a shutdown for the seal chamber, so if you get a seal leak, this float right here will shut it down. We also have quick disconnects on the hoses for draining each chamber. That makes it a lot easier to drain gear oil instead of waiting for it to drip out. We also have the clean outs on both tanks. We put a nice little 2-inch cam lock for priming it. If you didn't know, it's not vacuum assisted, so you have to prime these, which we even put a nice sticker here telling you where to fill it to. Another thing that we have, going back to our shutdowns, we have a low vacuum shutdown, so if this thing drops below 5 inches of vacuum for I think 5 minutes, it's going to shut down. That protects your lobes from overheating. I mean, 5 minutes of it's still going to have water in it. It's barely going to get lukewarm. If for whatever reason you're pulling high vacuum where that won't shut it down but not pumping any water, we also put a temperature probe right in one of the bolt holes on this flange. So that is set at 130 degrees. It's hard to see, but this line, it's just a basic temp probe, same one we use on some of our engines. So that's set at 130 degrees, so if for whatever reason you have high vacuum but no water, it will shut down that way. It can be very expensive to rebuild a rotary Lobe pump, but I think we probably do it better than anybody as far as protecting them. We do also put a zinc anode in the tank, so if you're using it in brackish water or seawater, it'll kind of help slow down the erosion of your pump and the corrosion. We do also have a intake screen that we put inside the pump here. You can kind of see the flange of it, but it's a nice intake screen. Keystone really won't even make it through there. You don't want anything going through these lobes. They are rubber coated. The rotary Lobe kind of come about because it's much simpler, has less components, a vac assist, which, you know, they do have their place in the market, but you got a vacuum pump bringing the water, you got a float that needs to shut off if it doesn't, you have contamination. You use less horsepower to run rotary, so they're more fuel efficient. As far as like the basic service on them, we do 1,000-hour interval, and we use gear oil across the board. So you have a seal chamber, you have your bearing chamber, and at the same time you'd want to do the PTO too. I'm not going to talk much about the PTO. It basically reduces the speed because these pumps max speed is 500 RPM. A lot of people think you need more vacuum to pump water, or you need the engine roaring to pump more water. It's not that at all. At 500 RPMs, this pump can pump, I think, close to 1,300 gallons a minute. Most of the time, if you're on SOC or you're on Wellpoints, you're not going to get that much water out of the ground unless you're near the ocean, maybe south, West Palm, Fort Myers area. So you're never going to pump that amount of water on a normal basis. Probably the most important thing about doing preventative maintenance on the rotaries, what we do here at Holland Pump, is we change the strain bolts every 2,000 hours. Even the factory doesn't recommend this or say you have to. They tell you to check the torque on them. We go ahead and change them every 2,000 hours because, you know, a pair of these bolts may cost you 60 bucks, but if one breaks, what happens in the field when it breaks, you don't hear it. It don't go making noise right away until it wears, and then you've worn lobes and the shaft, and that's where the expense comes in. So changing the bolts every 2,000 hours will make you a lot happier, because you don't want to get into replacing these because a set of lobes, it has 4 lobes in it, as you can see, these are like helix style lobes, but on an 8 it'll have 4, on a 12 it'll have 8 of them, and they can be quite costly. But if you do good preventative maintenance, you'll keep that cost down. So basically, this is how the lobes go in. They have a right and left. You know, if you put the right in first, the left, or you can alternate them. But the same way, if you put a right on the bottom, you'll put a left on the top, and then you alternate all the way out. So the helix is good versus a lot of like straight lobe pumps that tend to have problems pumping up out of holes. They don't really like, because it's kind of like a steady paddle. This thing's kind of like a screw, so it's a constant flow, more steady flow. But so this bolt, the other reason we changed it is this takes the brunt of everything. So this pressure disc go in here, it'll have an O-ring around here you'll want to change. It has an O-ring inside to seal up the head of the bolt that you'll want to change. On this, we have a key that fits right into the shaft, so everything turns together, so you don't get any over tightening of the bolt on startup or shutdown. It does have, if you can't get it out, it has like little set screws you can take out and put a puller on, like a little slide hammer or something, and pull them out. But yeah, this is probably the most important thing right here, is to keep these bolts changed. A lot of times when you buy one of our pumps, we'll have a lubrication record. One thing about testing a rotary pump, it is a positive displacement pump. What that means is, where a centrifugal has to evacuate the air before to catch prime and pump, positive displacement pumps, they pump water, they pump air, they pump it all at the same time. So if I had a problem on a centrifugal pump and it was low vacuum because they have a discharge valve, I may blank off the discharge to see if the discharge valve was leaking. Never ever do that on a positive displacement pump. It will, you know, you could get hurt if it blew the cap off. I've seen it blow pipe in half when somebody had a valve closed on one. They pump air, even if that's all they got to pump, they'll pump air. So they're very dangerous in that aspect. Never restrict it. You know, don't put 4-inch lay flat on an 8-inch or 12-inch pump. You'll cause cavitation and really violent. So a few things to troubleshoot on these, and I'm going to go briefly, and then I have a sheet that I've created that will show at the end of this as far as all the checks, if it's on header or sock, and low vacuum, high vacuum situations. But one thing, like I spoke of earlier in the video, people think you need 30 inches of vacuum to pull water. You really need about 1 inch of vacuum for every foot of lift. What you want to do is you want to bring that water as easily as you can. You know, if you put 30 inches of vacuum on it and you have silt or you have clay in the ground, what you're doing is you're pulling that silt and clay around your sock or around your Wellpoint, and then it's not going to let water in. So you want to, you know, I say if you got 20-foot sock, you know, and a couple foot of lift, no more than 22 inches. But really, I used to tell people 20. That seemed to be a really good safe thing on sock. You didn't tend to collapse the sock or anything, or on header. But if you put too much vacuum on this pump's going to talk to you. What it's going to do is it's going to start to cavitate, because you're trying to bring the water faster than than it wants to come, that the ground will give up. So this pump, and you may notice it when you're testing it, when you have your hand over it, it'll rumble. And what that's doing is it's cavitating. So what you're doing is that water's turning to vapor before it comes in here, and that's just little explosions. Happens on all pumps, centrifugal and everything. What this pump is telling you is you got too much vacuum for what you need. You're trying to bring it too fast. Like I said, these things are pumped, this model, 1,1300 gallons a minute. Most times you're not going to be bringing that much water. So just remember, 1 for 1. 1 inch of vacuum for every foot of lift, and you'll be okay. All right, just a couple quick troubleshooting things. Let's say you have a pump, it's pulling good vacuum, you know, it's pulling 20 inches of vacuum, but you ain't hardly getting any water out the discharge. One thing you would want to check is the intake screen. Even though sock, you know, which is a corrugated pipe flex, it has a sock that goes over it so it filters the water, and in Wellpoints filter the water sometimes either or can break. The sock can get damaged when it's getting put in the ground by the machine, or the Wellpoint could be damaged a little bit, and when they put it down in the ground, the end of the screen breaks off and you suck up. You know, if they're using, I know we sand our points, some people like using pea stone and stuff like that, but anyway, that screen, I've seen them packed. So basically what you're doing is when you pack that screen is you're kind of like deadheading, and what we call deadheading and testing it, because you're putting a blank over it. So that would be the first thing I would check. If you have a low vacuum situation, the first thing I would check is your tank. So pop this off. I put a stick down in them. You can look down in them, but you know, if it has this much water or this much water, it's hard to tell. So I put a stick down in them, and you got to remember it's got to be at least that full to get in here. So you'd always want it up to here. So a lot of times if a swing gets knocked off, or sometimes when you shut a pump off on header, just the back, because it's got all this vacuum, the pipe is, all the air in the pipe's evacuating. When you shut it off, it rushes back so hard it'll blow the end cap off it, or blow the swing out. And you know, the fuel guy, he's just fueling it up, checking the oil, and he starts to back up, leaves, it's not pumping any water. So if you're not pulling any vacuum, the first test, always bring your blank in, fill your tanks up, deadhead the pump, make sure it holds, you know, 25 plus for a good 20-30 seconds, and eliminate the pump, and then you can work your way back if you don't have a vacuum. And a lot of times people with sock, this stuff's put in with this big trenching machine, and it comes out, and what they do is they cut it as short as they can to get it up in here, because they don't want it getting sucked up in there, which we have a grate to stop the sock, but they cut it so short, and it's corrugated, so when vacuum hits it, it contracts, and when it contracts, normally right where it comes out of the ground, it'll collapse. That's one thing. The other thing is, like I said earlier, you're putting too much vacuum on it, you're in silt or clay, the ground's not giving up a lot of water, that could be it. But always eliminate your pump first, and then work your way back on that. As far as on the discharge side, like I said, don't ever restrict it, but that's pretty much it. We'll put the sheet up at the end. It's a much more talks about everything low vacuum, high vacuum situations. As far as like oil changes and everything, I would recommend you refer to the manufacturer's manual on the service intervals. So most of them nowadays are around 500 hours. Here at Holland Pump, we try to keep it under 360 hours. You want to use a quality 15W40 motor oil. So right now I'm just going to go over a few things. So as far as like the fuel system on these, it's very important today to keep your fuel filters changed. We change them every 2 weeks. We change them when we deliver the pump and set them up. All our pumps should go from the tank through a water separator, through the lift pump, and into the fuel system. Now a lot of engines will also have screens in the lift pump, so this one does have a screen. You'd want to keep that clean too. You can just pull them out, hit them with a little brake cleaner, let them dry off, and reinstall them. So, but very important to keep your fuel system clean. It really helps the longevity of your engine. So next, as far as like the oil on these, all our pumps come with a quick disconnect. You can get any little oil pump from Granger's or wherever mounted on a bucket, and a little 12 volt. You can hook them right up to the battery and drain your oil through that. I do recommend when you're draining anything and creating vacuum inside a engine to, you know, either pull the dipstick out or take the oil filled cap off so you don't create a vacuum in there and damage seals. But like I said, I'd refer to the engine manufacturer. You should get a book when you purchase a pump from us that has all the maintenance on the engine and everything. So like I said, most new engines are around 500 hour, but we try to keep them under 360, and we get a long life, average life out of all our engines here because of that.